because I have a hard time, always, reading stuff and focusing on what people say. Plus, I think what I'm going to say is not very complicated, because the details I find are too complicated to put there and for you to understand. You can read about it, so that's not the problem. Thank you for the invitation to speak here. I have a sort of previous life in logic, so I used to do logic, but always with an eye to language. Now that I am officially a linguist, though computational linguist, I find myself going back and forth between language and logic. And one of the areas I found most interesting was, space. Partly because a trained mathematician finds space, very, congenial. So there's something you can do. Actually, it is a very interesting domain, because it has thrown up lots of questions, not only for semantics. So let me say this before I start. I actually think that model theoretic semantics is in disarray, partly because people have given up. So once you go into situations and events, you don't see any models. People just have formulas. They write, there is an event such that. And I look at it in despair and say, where's the model? I don't know, And it is actually troubling. So, I find that without knowing where the events are and what they are, I can't tell whether this makes sense. So, in effect, people have sort of, I think, tacitly given up on models as such, which is a shame. Apart from the kind of trivial saying, that they understand how to work this, but there's no reason for doing this. I mean, after all, the litmus test for semantics is that you can go out and check a sentence whether it is true or not. So when you talk about space, it is a very easy method, yeah? So you talk about a sentence, you give people something to look at, Let's say here's a watch, and you say, is the watch next to the glasses? So people answer, yes? So it's very direct, I think as direct as it can get at all. So it's for someone who wants to do experiments, this is an easy thing to do. However, I think it's become clear to people that there are different kinds of models to be looked at. So one, there is the cognitive model. So cognitive linguists are really very often talking about, what's going on inside the head, right? So what is it that, what is the model that we're building inside the head? And some stop there as if to say that this is enough, right? But I don't think, it shouldn't be, because, we have this idea that there is a reality outside that we look at, and whether or not we're talking the same talk or understand, things the same way is by checking out if we reach the same conclusions, in a physical world. Okay, so space comes in then as the study of the model, which is the world, right? So as, we all believe in some external reality, which we call the world, and part of it is space. So in comes physics as the theory of space, right? And we have to take this some more seriously. So then you have two kinds of models. One is the physical, the other is the cognitive. And then you have language, where you have, a syntax and meaning to go with it. So you have to ask yourself, how do I interpret complex expressions? All right. So spatial expressions have actually sort of started to throw up many problems. One of them is, they're complex. You say a rat emerged from under the table. So suddenly you have two prepositions, from, under. You have to make sense of them. Actually, if you look at case systems, this is how I got started. Case systems, morphology in various languages. So Indo-European is quite poor, but go to Uralic languages, take Finnish, take Hungarian, go to Caucasus, right? Rich morphology with space, and there's always the same thing. There's a dichotomy between, place and change that keeps popping up everywhere. So people have noticed this without actually, being able to sort of put up a clean semantics on the table. And then later, also work by Peter Svenonius and others have shown that it is even more complicated than that. So eventually they have proposed that there's a hierarchy. So you start with a landmark, NP or DP as you want to call it, and then there are stages of construction. So you have several heads, sometimes 3 or 4, that get meshed into 1 or 2 prepositions or cases until you're done. So this has implications for syntax also, which I have looked at some point, but this is not what I'm going to talk about here. Instead, when I started to look at the semantics, the meaning of expressions, spatial expressions, first I did the sort of standard task, model theory. You have your model, I actually used some events, and then you map out the meanings of these expressions one by one. So basic ideas in Montague, we had this theme come up yesterday as well, compositionality, right? So, with my background, I worry about having 2 expressions with their meanings, you put them together, you need to be able to predict what the complex expression means. So starting with something like the table, you want to say what under means so that under the table gives you a location. And then adding the expression from, you want to be able to say what this then means, right? So this can be done and has been done. So Peter actually gave you some indication. So the idea is that under, in first approximation, is a relation between points, let's say, right? So here you have a point, here you have another point. So, note that I'm talking about pure space. There's nothing else, right? And then this point is under that point, right? So you have a spatial relation be a relation between points. Now, eventually, you will sort of find that it might be more appropriate to talk about regions. So you have, a table like this, and you have a rat like this, and then you ask yourself, well, is it under the table or not? And that should be, in principle, at least now, answerable just by looking at the locations these 2 things occupy. So, by a kind of funny exercise, you first have the 2 objects, call them landmark and figure, right? Or ground and figure. And then you take them away and you just maintain the location that they occupy. I call that the solid, right? So, or eigenspace, if you want. And then you just look at that and you say yes or no, right? And by that, you can identify then, at that very moment, whether the rat is under the table. So that's the first step. Second step then is the from part, right? Where you say, well, it expresses a change, right? So work by Vivienne Fong and others, she has identified this as a phase quantifier. So the idea is that it's a change of truth value of the expression of the sentence, the rat is under the table, right? So it changes from being true to being false. So in effect, then, this word from in this construction means that some proposition changes truth value over time. And as for time, we just take the interval of the event that is denoted, right? So you have a verb. A verb denotes some kind of event. That event has a temporal trace, an interval, and you look at the sort of profile of this expression. The proposition is the rat is under the table. And then, it is true and then it is false. This means if you're just doing, if you're just having two truth values, you have a sudden change in truth value. But, you can accommodate by letting it be, degrees of fit or degrees of truth. Then you have just a smooth curve, so it goes from being true to being false in a sort of continuous way. So that's not a problem. By that, you can actually also accommodate for towards, so what they call approximation and recession. I should at this point also refer to the work by Igor Malchuk, Éléments de cours de morphologie générale, so where he actually has entire terminology of these things, and he does the same thing. He separates out these two components. One about the location, let's say, at a particular point, and then another to talk about the change of the truth of this expression. Yeah? Okay. So this can be done, and it works, let's say, but it's not satisfying. So one problem that I had with it is that it simply allows for too many meanings, just way too many. And it's unsatisfactory in many respects. How can I make this clear? Maybe the easiest is this lack of change where you do expect it. So, my examples involve, pardon me, Michael Schumacher and Mika Hakkinen. We're talking 90s, right? But I haven't followed the, charts, in Formula One racing. So you have Mika and Michael, and Michael is, eager to overtake Mika Hakkinen, so he's, driving behind. So, you watch it and you say, Michael is staying behind Mika, right? So what does that mean? I mean, he's racing, right? They're all in motion. This is, so they're sort of zooming past the audience. So there's clear evidence that they are in motion. Nevertheless, for some reason, the relation is behind stays put, right? It remains true. Yeah? So what's the explanation? Yeah? The explanation is simple. You calculate from a certain, origo, let's say. So when you evaluate the truth of that sentence, you don't take your perspective and say, well, they are moving. Instead, the ground is actually the center of the coordinate frame. And it goes along with that ground. You see what I mean? So it is, when you have, sometimes I show you these pictures, you have a camera inside the car, right? So it is, this is Mika driving along. So, from his perspective, he's always behind. So he stays put in the coordinate system. and so does the relation, right, between them. Okay? So that's very simple. So what is to be done then, right? What is to be done is to actually change the semantics to make that come out natural. Because studying, spatial PPs, in no matter what language you choose, it's always the same thing. It is the fact that a spatial prepositional phrase has as a center of origin always the ground, no one else, right? At first instance. We can talk about the complications. And, pardon me, because I wrote this abstract and I said, you can't use vectors, you can't use triples of coordinates. This is not to say that, there's anything wrong with using them, but I think I want to sort of put some justification below the whole thing so that the meanings come out as to be much simpler than they look at surface, right? So it's not that you can't do it, it's just that I found something more attractive in this. So some excursion then into, let's say, physics, which is also very interesting. I think, in some sense, at least this is my own impression of myself, we have been brainwashed by the Cartesian change, right? So in Cartesian, by that I don't mean philosophy, but I mean the, coordinate frames. I mean, modern society is based on numbers all along, right? So where you are in space, you can locate yourself, at least on Earth, by using these coordinates, with respect to some place in Greenwich, right? So it can be done, right? So there's a way to track everyone's position by a pair of numbers, or maybe a triple. And we use that all the time. We basically don't rely on our intuition the same way, but what time it is. But we constantly use this. Right? I have this because I keep track of how much time I have. Yeah. So we use these instruments, but we don't talk like that. I mean, we don't talk using instruments. So in first instance, we don't have these numbers. But you come out of school, thinking that this is the way to go, right? And there's a predicament that physicists have found, you probably have heard of it. This is the ether theory, right? So people think intuitively of space as a container, right? So it's there, it stays put. And you think, well, how else could it be? What can it, what is motion of space? I don't know. So anyway, so you take an object and you put it there in space. So by that, then, they reason that even a single object in space could be said to move, just because its position with respect to the space changes, right? So that was the common theory. Mind you, even at that time, people said that physical laws had to be invariant under translation, which means that you shift the coordinates frame and your laws, the way you phrase them, shouldn't move, okay? They should not change. Now, this theory was dealt a blow in 1887. This is Michelson-Morley experiment, right? So what they found is that no matter where you go, in direction of the Earth's movement or against, or how you turn it, the speed of light is always the same, right? How can this be? Because it means that there is no ether to move, against. And actually, what I found most congenial here is Mach's principle. I mean, Mach says, consider the universe as consisting of just one sphere. And I'll think of that sphere as rotating. What are all these forces doing? Centripetal force, whatever. They're nil. Why? Because the sphere cannot know it's rotating. There is no rotation because there's, yeah? So he says, I mean, I have the wording here. Let me see. It's a very interesting principle if you care to know. Any phenomena that would seem attributable to absolute space and time, such as inertia and centrifugal force, should instead be seen as emerging from the large-scale distribution of matter in the universe. So this keeps me thinking. I mean, it's not, the funny thing is that as I think about it, it's the same problem that we humans have because we can't figure out these numbers. We can't. And any physical object has. How can it tell it is moving, right? So it's the same problem. And that means we need to look at space in a different way. Though I should say the solution is different for the physicists as it is for, in cognition. I actually happen to think that we are still far away from a sort of unified theory. Okay, so what is it that I'm proposing? I'm proposing, first of all, that for starters, we still keep with the notion of an absolute space. So, you're a mathematician, or I am, I think that, okay, space is just a set of points, and there are some relations on them. Let's not be too specific, but you still think of space as a container, and there are points in it, and you have some relations. Let's say some distance metric, some notion of a straight line. What is a straight line, and so on. Yeah. So it's a structure. It's actually more complicated than just just a set. Okay. But mind you, there are no coordinates, nothing. So there's no way to point at a spatial point other than by saying here, right? Actually, here is as good as it gets. Yeah, this is purely spatial. Okay. And there are no coordinates to begin with. I think they don't exist. I mean, let's say semantically. So your model just has this structure with points. So then what happens? As you construct your PP, from under the table or on the mat or whatever. I mean, there are languages that have special cases devoted to the notion, to on, right? The cat is going on the mat, or from, and so on. So many, yeah? So as you're doing this, suddenly you introduce an object, yeah? The mat or the table. So as you put that object there, your notion of space changes. Yeah? I call that aspect. So the idea is that the way you address the points, the way you talk about points, the way you code the space becomes different. Suddenly, everything is looked at with reference to that point. Let's say, and for this instance, if you have a bigger object, you will take the center of mass or something. Yeah. So there you have a point, and then every other point denotes a vector. There you go. You have your vector. Yeah. Yeah. So this is a very basic notion in geometry. So vectors arise from choosing just an origin. So now you can talk about actually shifting, you have vectors and so on. That's the first step, right? And actually what happens is that your space as you recode it, actually becomes a vector space. You have vectors, you can add these vectors now, you can subtract them, and so it all becomes definable by very elementary definitions. So just by adding a point. That is, before you just had a space and a point, but after that you have a vector space. What you don't yet have is coordinates, all right? You just have vectors. Okay. And then something happens, and I think that's important because it comes up in many places, and I've seen very little work be done on that problem, with the exception of maybe Kees van Meulen and Henk Verkuil. They wrote on the problem of, now, how big is now, right? So how big is here? We had this, I think, with respect to home, how big is home, yeah? Immediately, you are talking about a scale. So I think, at first you have this vector space, but you don't have any numbers to go with. Your vectors are just plain vectors. But then, when you talk about, let's say, something near something else, so you want to ask something like, is this clock near to the glasses? You would say yes, okay. And when I do this, you would say no, right? Curiously enough, it depends on how big the objects are. If there are stars or, two elephants, right? This elephant be near to that elephant, depends, it's a bigger distance where you say, well, yes, right? So it is actually, it depends on the relative size. And mind you, look at a map. You see, is New Zealand near to Australia? You look at it and say, yes. Oh, wow, we're talking 2-hour flight or something, right? But you don't look at the scale there. You don't look at it and say, oh, it's 1,000,000 to 1 or something, yeah? So in fact, scales very often don't matter at all. Sometimes they do, so, it's not always scaled the same way. But I think in most instances, it is. And so there's a further step then to introduce a scale, right? How do you do this? Well, you pick a unit vector. So far, you just have vectors. So now you say, so I pick this vector. This has distance 1. Yeah? How you do that is a matter of sort of it depends. So people have studied frames of reference for a long time, and there it's the same problem. It depends on the lexical item and so on and so on. But all I'm saying is that there is an additional step you make. You call in the distance. You say, well, this is a unit then. And that step then sort of makes it a norm vector space. So suddenly you can talk about distances. And the next step is, you say, this is sometimes called your positioning an observer. So you have your, ground for purposes, let's say, let's talk about Mika again, right? So he's your observer. So, conveniently, he's already positioned the right way, yeah? So he's actually facing the way he's going, yeah? So it's canonical observer. So he's there. What does that mean? It means you have up, down, left, right, and so on, yeah? Front, back. You have these 6 cardinal directions. You have a coordinate frame. And now you can talk distances, directions, and if you like, Peter, we can talk polar coordinates, yeah? So actually, I think, to go back to this question, what kind of frame should we use? I think it's something that emerges while you're constructing your PP. And some of the steps are actually unnecessary. That's what I think. So, for example, when you talk about nearness, near, far, there's no need to talk coordinate frames. You don't have to pick directions. You just don't. You just measure distance, right? So here is an actual proposal that I make. Yeah, this is my fan club. They're very happy I'm making this proposal. All right? So what I'm saying is that what we used to think of as the meaning, yeah? Say near means has to be this size in relation to that and so on, so becomes a burden on the, what I call aspect. So actually, distance is then just sort of saying, it has to be, 1 to 2 or 1 to 3 or something, yeah? Some interval. And you're placing the burden on the way you look at space, what I call its aspect. So when you look at the map of Australia and New Zealand, that already calculates some coding of a real space of which you might not be aware. But you look at it and you say, well, yes. Even if they tell you that it's a map, even so you would say the same, right? It's independent of the fact that, that it is a map, or you know about it. So what happens is that in between, before you actually assess the truth or falsity or whatever, you actually recode the space itself. And now it becomes clear how you want to deal with motion. It's the same thing. You see, as the ground moves around, Mika is driving, so your coordinate frame moves with it. So what appeared to be a relation between two objects, calculated in terms of whatever routine you have, now becomes a simple question of, is this one object, positioned in a certain region inside the coordinate frame? Because the coordinate frame goes with the ground, yeah? So by placing part of the burden into the aspect, you can actually free yourself of this horrible dependency on, talking about two objects and coordinates and so on. Actually, you have a coordinate frame there. You can then reduce the meaning of directional expressions, left, right, and so on, to very basic things, right? They become very basic. All the burden is in choosing the coordinate frame. This is what people have identified already, right? But I'm just making it palatable to, let's say, moral theoretic semantics. It changes the way you think about matter in model theory more than it does in cognition. Yeah? And what it does is, when you do this, you understand how certain things appear to be not changing while an outside observer still thinks that there is change, right? So there is a race, two cars are moving, and yet the relation stays put, right? Even though it's a spatial relation. Yeah, it's a very easy exercise. Just in between, there are some facts to note here. There's work by Urpo Nikan on positions and finish. So they can be prepositions or postpositions. And he knows that they come in three kinds. One, these are the ones that we are used to. They are sort of neutral. But there is the first category, which you can use only if the ground is in motion, and the other where you can only use when the ground is not in motion, right? This is not contradicting what I'm saying. It is, it's a check you have to make on your ground, right? So, you can use certain prepositions only or postpositions only, let's say if your ground is fixed. Mind you, and you can use a verb in that same sentence, yeah, indicating motion, and still, the spatial configuration stays put, yeah? So it's not contradicting, but I think you cannot do much more than that. So, checking out meanings of prepositional phrases all over the world, I have come to the conclusion that I don't see any exceptions to the rule as far as that goes. Of course, the big secret is, when you look at, let's say, the work by Levinson and so on, the big secret is, for example, what do these directions attend to? We have these absolute systems, north, south. You have relative systems, left, right, and so on. So there are many, many factors that go into the choice of coordinate vectors. And they can pose a problem for a simple compositionality principle. So at this point, I have to say that someone like me who's doing the, strict compositionality really faces problems because it is not really clear how to do this in a compositional manner when you have to track the aspect in parallel to your meanings. Because what you do is, you express the things differently, but when you want to see how they play out in reality, you have to understand that you've put on one filter after another. Yeah? So first you chose a ground, then you chose this unit, then some directions, and suddenly you talk about behind, front, and above, and so on. Yeah? So you have these added filters. They remove you sort of from the reality. So from a model theoretic perspective, when you want to see, what exactly does it mean? What point am I talking about? Yeah, you have to sort of undo the coding, as it were. Yeah? And in model theory or model theoretic semantics, that needs a lot of care. So I don't want to go into this now, because I think that essentially then, I think, for me at least, the solution lies elsewhere. So if I were to speculate on how a model theoretic, like me, a semanticist, would actually have to run the show, right? See, the problem is this. I still have to give an answer to how we can identify points. So if everything is just, relative to whatever, how can I, essentially, how can I put an object into some uninhabited space if I don't have a means to say what the points are, right? Strangely enough. Do you understand me? We have the same problem as a physicist. Space exists only as a, room filled with furniture. We have no way of talking about place as such, ever. Even physicists don't have it. So where is that space, right? Well, I think this is a sort of Kantian theme, right? I think the space is being constructed. So essentially, in reality, I think this is what we do. we still have the idea that there is space out there where we move in. But, you know, when I want to understand what things mean, it's hardly possible for me to sort of, you know, use the space out there. I still have to figure out inside myself with the model or, you know, in me, what that actually means. So if I pretend that there is a space, what space is it? And I think we're actually making the space out of the existence that is, you know, this is what a lot of what cognition is about, you know, landmarks and so on. I mean, how do I remember where I am or was last time and so on, yeah? How do I make reference to myself in this? So how do I know I'm in the same location today as I was yesterday? You see, I don't do it by means of absolute space, no matter how I search my own model inside. That's not the way I can tell. That's not the way I do tell. Rather, I say, well, you know, this podium is the one I saw yesterday, right? So this is the walk I walked yesterday, and so on. So suddenly it matters with respect to objects and their placements. So actually, when we come to think of the model in our head, let's say, by means of which we evaluate sentences, right? That model is created pretty much the same way as, you know, everybody else has been talking about, by means of a very complicated process. Much similar to, I'm returning to physics, you know. I mean, this is a very fascinating subject, you know. How do physicists actually get to tell whether either this is 1 meter apart? You know, I mean, just check it out. It's a very long history of, you know, fixing the distances and so on, and actually reassuring that this distance, as you know, go along and measure it, it's the same all over. And I think as we grow up, we do the same. We register that the relative distances of certain objects just don't change by whatever means we're able to check, right? Yeah, so houses, for example, and trees, you know, trees less so, but yeah. So actually, we are constructing the space out of things. And so that's the way we actually make reference to them. And I think, without being able to tell you exactly how, I think there will be the ultimate solution to the question, you know, how can a modern theoretic semanticist actually make peace with this very strange notion of aspect and, you know, putting on one filter after another to look at your reality. Thank you very much.
We have some time for questions. Jessica?
Hi, I'm interested, like Peter, in the parallels across types of semantic types of things. And I was wondering about the extent to which space is unique in the sense you describe. It reminded me, your use of the term aspect reminded me of the phenomenon I know as domain restriction, contextual domain restriction. So if a bunch of us go to dinner, I can say to the waitress, everyone wants a beer, and I don't mean everyone in the world. This can happen linguistically as well. I can just say out of the blue, everyone was late to class. And you take the sort of linguistic context to constrain that to mean everyone enrolled in the class and so forth and so on. So in that respect, even when we're talking about pluralities of individuals, we seem to be using other cues to constrain our reference. And I was just wondering if you thought that related to your notion of aspect, and if so, how?
Yes. Actually, I think essentially aspect is more flexible than meaning. So, you know, part of the exercise was to say, well, there are some core parts of meaning that are very easy to pinpoint. I mean, let's say you read in a book, strange language. What does this preposition mean? I say, it's up or down. So they just give you, one vector. That's it. And suddenly you are able to sort of deduce from that, by some principles, how exactly that fans out. Yeah. However, there are many, many things. We have talked about context dependency, right? I think the construction of aspects, so this is kind of the thing that gets invoked when you actually create a complex constituent. It means you have to adapt also the way you code, let's say, your space in this connection. And that, I think, uses some flexibility. You always want to ask for what purpose. So like scaling, whether you want to say something is near or far, it depends on what kind of scale you want to use. I said initially you want to take into account the size of the objects. But sometimes we want to use a human scale, right? Near in terms of, what we, yeah? Or when I say, I'm near to your house, I'm on a bicycle. So that means it's just going to take a few minutes. But, in terms of pure distance, it's not near. So there lies the flexibility, there lies the context dependency, and so on. So I want to free the meanings of this. Yeah?
More questions? I have a sort of a follow-up to Jessica's question. Basically, I think there are two possible directions to go, for instance, to treat, for instance, cases like what Peter mentioned with the ball hanging from Hershkovitz's book, or the ball hanging in the ball in one case, not in the ball in the other case. One way to go is to say, basically, that's within the meaning of the preposition. So support, as Peter suggested, is part of the meaning of the preposition. Another way, which I think you are more sympathetic with, is to say in has some abstract topological meaning or set theoretical meaning with respect to some abstract space, and then what you call aspect is a way of changing the eigenspaces of the object, if I understand correctly what you are saying. Right? So we can talk basically about two ways to go. One is to study specific prepositions with respect to such constructions and to kind of attribute the variability in the meaning of the preposition itself. And then languages might differ in that respect and so on. Another way is to say basically we have general strategies that allow us to kind of reconstruct space, perhaps along the lines of what you're suggesting. Maybe there is another way that I don't precisely follow, but I would be interested to know if there are different ways to go here. Am I right in this kind of categorization? And once we have those different ways, is there any empirical way you can think of to decide between them?
Well, it's maybe less empirical. I mean, it's not empirical. That's what I claim. First of all, the notion of aspect is can be generalized to many things. I mean, you can say, okay, so I change the way I look at space. So why don't I use space for something else? So I have a different map that transfers this to another domain. That's entirely possible. I think the term aspect was actually I chose the word on purpose to align it with tense. I think the problem with temporal semantics is pretty much the same. Whenever I read about it, I get dizzy because people talk about an event presented as being ongoing and something like that. I don't know what that means. I mean, pardon me, I understand what people want to say, but when I put on my model theory, it's there's something I'm missing. So actually, I think the missing part is the how you code your time there. I think it can be done straight away. Now, if you can, whether you can go into other domains or not, and how this can be done safely, I don't know. The only thing I have sort of looked at is, I don't know if you're familiar with the word by Fred Landman. Basically, what used to be the task of syntax to regulate how you can put things together, everything gets shoved into the semantics, right? And the trick is to recode all the time. Out of principle, I reject this. I think meanings are simple, and you cannot just, adopt them at random. If anything, I would go for what has been done in semantics all along. In a particular construction, you could, recode. Let's say curry is a matter of recoding your function into some other function. So this kind of idea, as much as it's used in category theory, natural equivalences and so on. I mean, maybe that's the way to go. With the metaphors or other domains, I have to look into this. I don't know.
At the beginning of your talk, you said that semanticists have more or less given up on model theory, and you seem to...
Sorry?
Semanticists have given up on model theory, and you seem to complain that this is bad. I have a diagnosis, and I also have a rather egocentric proposal. And the diagnosis is that model theory started out with people in logic and in linguistics like Montague and Creswell and others. And the primitives of model theory were possible worlds and sets of possible worlds. Truth conditions were defined in terms of possible worlds. And you could use them for analyze quantifiers and logical operators, but you couldn't really use them to analyze content words like the ones we've been talking about here, spatial relations and so on. I mean, you can do it in a certain sense. But my basic diagnosis is that the ontology of model theory is set theory. I mean, you talk about sets of theory, sets of possible worlds, you do intersection and negation, complement, and I mean all the set theoretical operations. That's not a very productive ontology. It's very abstract, and it doesn't fit with human cognition at all. I mean, our brains most likely don't work in set theoretical structures. So that's my diagnosis, why model theory has had some problems with semantic analysis when you do semantics of natural languages. My proposal is, and this is my egocentric part here, is that if you replace this set theoretical ontology with something like a spatial ontology, and now I bring in my conceptual spaces. I mean, it's not ordinary space only, but it's color space, it's force space, it's emotion space, and so on. Then you get a much richer structure, and you can define models in terms of these structures. I mean, I didn't do it today, but I mean, it's quite easy to develop this into a kind of model theory. And I would suggest, or I hope, that human cognition is much more attuned to this kind of spatial structures that I'm talking about. So we can do model theory, but we should do them on basis of spatial structures rather than on set theoretical structures.
Sure, yes, but the problem is, well, how can I say this? You know, it's easy to criticize these things, but on the other hand, once you put up a proposal, they say, oh, okay, we know how to do this. I mean, talk to a mathematician, you know, I mean, they know how to fill this, right? And then they come up with some mathematical structure that does it all, right? So I think there's nothing wrong. I mean, it is always the same problem. At some point you have to press the issue that this is for a particular reason. There is an interpretation to go with these things, right? It's not just picking, walk and then prime. Because, when Montague did it, he wasn't interested in the particular meaning of walks and talks, right? So, he did the quantification part. And then, again, this is an empirical issue, did he get it right or not? But at least they were talking quanta. And by the same token, you can get down and say, I mean, this is the line people have been following. Say much more precisely what verb meanings are, and so on, how they differentiate. But it's I think how shall I put it? I think the particular problem that arose was that at some point it just becomes unwieldy. When you do your events and situations and so on, nobody tells me in a model where the events are, then how can I say a formula is true or not? So that is the kind of problem I was referring to. And it would change if people were to give me exact criteria where to find the events. I used to ask people, how do I know there's an event of running? Tell me. I look at things going on. Where is the event of John running? I want the criterion, and I think it can be given, and then we're back to normal. So I think essentially, you can have it your way, it's no problem. We need to press the issue that this has a particular meaning you cannot change at random. We have to talk about this, right? Also that there's a real space. It's like, I used to do model logic, I don't know what a possible world is. You can dream up possible worlds. What is this? That's why I went into space, because I thought, I don't know what this is. But with space, at least, we have physics. So we can nail it down more concretely, rather than dreaming up worlds where Napoleon, was, not defeated at Waterloo. What do I know that happened?
We should discuss this over lunch or something. But let me just say that when it comes to event identification, that can be done totally non-linguistically. And people are quite in agreement when they are shown some movies or something, when an event begins and when it ends. Event segmentation is quite common. I mean, quite a lot of agreement among subjects on event segmentation. Then how that fits into linguistic structures is an open question, but I hope it does.
Yeah.
I hope it does.
Thank you.